All right, everybody, welcome to lesson number 9, putting it all together. So this is the last lesson of the chapter. We're basically kind of going to go over all the different skills that we learned throughout the last few lessons. Uh, there's going to be a couple proofs in here, but we're going to be using all of those algebraic skills, finding slope, finding distances, and so forth. One of the things that came up in this chapter that I always notice students struggle with is the idea of taking a segment and dividing it proportionally. So that's why the opening exercise is one of these questions. It's the end of the unit. Let's review something from earlier in the chapter. So the opening exercise gives us this line segment RW. It tells us that we want to separate RW into a ratio of 2 to 3. Now, if I have a 2 to 3 ratio, that's 2 parts versus 3 parts. So in total, we have 5 parts. And it wants us to find the coordinate of P. So because I don't have a piece of graph paper here, I'm just going to kind of sketch point R, which would be to the left, and point W, which would be somewhere over here to the right and a little bit higher. Looking at the X and Y values, I know that. So if I connect those 2 points, I then can figure out how much do I have to travel to the right and how much do I have to travel up to get from R to W. So to get from -4 to +6, I would travel to the right 10 units. To get from 5 to 20, I would travel up 15 units. Now, I want to take that slope, that's what I'm finding there, that slope, and divide it into 5 equal parts. So instead of going to the right 5, I want to go to the right 2. Instead of going up 15, I want to go up 3. That's going to give us a point on my line segment. If I do that again, go 2 and 3, 2 and 3, 2 and 3, I would separate into 5 equal parts. Now, this picture that I'm drawing is us just coming up with this idea of moving to the right 3 and up 3. If I make an X and Y table, starting with the original point, -4, 5, and remembering I'm going to go to the right 2, so that's going to add 2 to the X values, and up 3, that's going to add 3 to the Y values, I can determine all of the points that are on this line segment. So if I add 2 to -4, I have -2. Add 2 again, I'm at 0. Add 2 again, I'm at 2. Add 2 again, I'm at 4. And then add 2 one more time, I am now at 6. If I do the same thing in the Y column, add 3 to 5, I have 8. Add 3 to 8, I have 11, 14, 17, and then 20. Notice I'm stopping at the point 620 because that's the last point on my line segment. So now I want to choose a point here that's going to separate this into 2 parts versus 3 parts. The point 011 is going to do that. See, I have 2 points above and 3 points below 011, so 011 winds up being my answer. This was actually a Regents question, right? So you can see how they're going to ask the question. It's multiple choice. If you'd rather have graph paper to do this, you can totally just use a piece of graph paper and graph the points. Some people think that that's easier. I tend to like the system of just setting up the table of values. I think that's easier, but if you're a grapher, go ahead and graph it. Okay. So let's just jump right into a question. If we were in class, I would tell you to do the first part of example 1 yourself. I'd say we've already done parallelogram proofs. This is a parallelogram proof, so go ahead. So here I would like you to pause the video, plot your 4 points, and try and use slope to prove that this is a parallelogram. All right, so welcome back. Hopefully you tried this on your own, so you could go ahead here and check your work. So I graphed my 4 points. I found 4 slopes. So the slope of AB and CD were the same. They were both up 5 to the right 2. And the slopes of BC and AD, since they're horizontal lines, they have slopes of 0, so they're also the same. So I notice the opposite sides of this quadrilateral are parallel, therefore it's a parallelogram. So my sentence is ABCD is a parallelogram because the opposite sides are parallel to each other. I know they're parallel because they have the same slope. It then says point N lies on segment BC such that CDN is an isosceles triangle. State the coordinates of n and prove that quadrilateral ABN is an isosceles trapezoid. So point N is somewhere on segment BC. Point N can be any of these coordinates, but I want to make it so that the triangle CDN is isosceles. So to make CDN isosceles, I have to make it so that point N has the same exact length as CD. Well, to do that, I want to make sure it has the same slope. So to get from D to C, I want to the right 2 up 5. So if I go to the left 2 up 5, I'd be at this coordinate of 2, 2. So point N has a coordinate of 2, 2. That would make it so that this segment is congruent to this segment. I know that just because of slope. If the rise and the run are the same, then we have the same length segment. Now, this is actually not the only answer. There's another answer for point N. It makes the problem way more challenging to do, so we're not going to do it that way. We're going to go with this N value. All right, so if you're thinking that there's another way of doing it, just email me. I'll be happy to answer whether or not you did it right or not. But this is the easier way of doing it. So now we have this new segment, and I'm going to use a different color here just to highlight this new segment we've created. All right, so I have this new quadrilateral that's been formed. Quadrilateral ABND. ABND has one set of parallel sides. BN has a slope of 0, AD has a slope of 0. But these two sides, AB and ND, are not parallel to each other, making this no longer a parallelogram, but a trapezoid. It also wants us to prove that this is an isosceles trapezoid. In an isosceles trapezoid, two of the sides are going to be the same length. So we have to figure out what is the length of AB, and we have to find the length of ND. Two distance formula problems. So to get from A to B, if I subtract my x values, so my x values of A and B would be -2 minus -4. And the y values of A and B would be 2 minus -3. So if I do that quick calculation in my calculator, if I plug everything in there except for the square root, I'm going to get 29. So I have the square root of 29 for segment AB. For segment ND, I have the coordinate of 2, 2, and I have the coordinate of 4, 3. So if I subtract my x values, 2 minus 4 squared, and 2 minus -3 squared. I'm going to plug that into my calculator as well, and I'm going to say I also get the square root of 29, making it so that AB and ND are actually the same length, making this not just a trapezoid, but an isosceles trapezoid. So I can say, therefore, A, B, and D is an isosceles trapezoid. And I'm actually going to state two things here. So I have to first state the fact that it's a trapezoid. So why did we know it was a trapezoid? Because AD was parallel to BN. They had the same slope. We already found their slopes up here. They both had slopes of 0. And the two segments we saw that had the same distance, AB and ND, well, they're congruent to each other. Number two asks us to prove that this is a trapezoid, but not an isosceles trapezoid. So again, to prove something's a trapezoid, we're just proving that one set of sides are parallel, so we need slope for that. To prove it's not isosceles, I have to show that the two non-parallel sides are not the same length, so we would need distances for that. So let's go ahead and start graphing. So we have the point 1, 3, 3, 1, 3, -3, and -1, +1. So I have this kind of awkward looking quadrilateral. We could label this trap, T-R-A-P. P, trap for trapezoid, not for trap house. That's a fun little math joke there, right? So let's take a look here. So if I was to say that this is a trapezoid, what sides look parallel? TR and PA look parallel. So I'm going to find their slopes first, and hopefully I have the right guess here. So the slope of TR, it's a negative sloped line. It goes down 2 to the right 2. Negative 2 over 2, which reduces to negative 1. The slope of PA, that's going to be down 4 to the right 4, negative 4 over 4. So I don't know why I wrote 2 there. Negative 4 over 4, so negative 1. That alone, that little tiny bit of work that I just did, is proving half of this problem. I can now say trap is a trapezoid because opposite sides are parallel. Right, so we have one set of opposite sides parallel, making this a trapezoid. Now, to prove that this is not isosceles, I have to show that TP is not the same length as RA. Now, they don't even look like they're the same length, but I have to show my work. Now, luckily, one of these distances is really easy to find. The distance of RA, since it's a vertical line, I could literally just count boxes. There's 4 boxes there, so that distance is 4. The distance of TP, well, I have to use the distance formula there because I have a diagonal line. So from P to T, so if I look at the points P and T, subtract the x values, so I have negative 1 minus 1 squared plus 1 minus 3 squared. So the distance of TP is going to be the square root of whatever that number comes out to be. So if I do some quick math in my calculator, I get the square root of 8. The square root of 8 is not 4. So I can say, therefore, trap is not isosceles because RA is not equal to TP. I forgot an E in here. It then says point B lies on segment AP such that the quadrilateral BRTP is a square. So if you look, TPR, that makes a right angle, right? I have a slope of positive 1, I have a slope of negative 1. So all I have to do is figure out what point over here would make this a square. I'm just going to use my slope to do that. So to get from T to R, I go down 2 to the right 2. So I'll just go opposite. I'll go to the left 2, down 2. And that new point winds up becoming point B. So I have square BRTP. So the point B that they're looking for is the coordinate 1, negative 1. It then says to prove that this is a square. So to prove something's a square, we need to prove that it has opposite sides that are parallel. I need to know it's a parallelogram. I need to know that all 4 sides are congruent, meaning I need to find 2 consecutive sides that are congruent. And I need to state that 2 consecutive sides are also perpendicular. So I need the slope of all of these sides. I need the slope of TP, which we already found is positive 1, right, up 2 to the right 2. The slope of TR, which I already found was negative 1. The slope of PB, that's down 2 to the right 2, so that's going to be negative 1. And the slope of BR, that's positive 1. Just that little bit of work helps prove that it's a parallelogram, and it helps prove that the segments are going to be perpendicular because these slopes are negative reciprocals. The other work I need to show is I need to pick 2 consecutive sides. It does not matter which ones. So I'll say TP, since I already found the distance of that one. And another side, let's say TR. All right, I already found the distance of TP here, so I could just bring that piece down. Let's not do more work than we have to. So to get from T to R, if I subtract my X values, I have 3 minus 1 squared plus 1 minus 3 squared, which if I type that into my calculator also gives me 8. So now I know that we have parallel sides, making it a parallelogram. I have perpendicular consecutive sides, making it a rectangle or a square. And I have consecutive sides that are congruent, making it a square. So now I can write my final sentence. So I can say, therefore, BRTP is a parallelogram. Because remember, you have to say it's a parallelogram first. Because opposite sides are parallel. Then I can say it's a square, and we'll use the two specific things that make it a square. So I'll say BRTP is a square because consecutive sides are both, to be a square, both of these things have to be true, congruent and perpendicular. Right, so to make something a square, the consecutive sides have to be both perpendicular and congruent. It has to be both. Okay, square is the most work always. All right, let's keep going. So number 3 asks us to prove that this is again a parallelogram. So here I'm going to have you pause the video and see if you could do this part by yourself. We'll do the second part together. All right, so let's take a look here. So it says to find whether or not this is a parallelogram. So I found the slope of all 4 sides. A, B, and CD were both 4 over 6, which reduces to 2/3. If you didn't reduce it, it's no big deal. And the slope of AB and BC both were negative 8 over 2, which also reduces to negative 4. So because both sets of opposite sides are parallel or have the same slope, I can then say it's a parallelogram because the opposite sides are parallel. Again, the work matches your sentence. The sentence is the big part. It then says point K is the midpoint of segment AD. So for segment AD, and I'll use a different color here, right? So from A to D, I went down 8 to the right 2. So if I go down half of that, so go down 4, 1, 2, 3, 4 to the right 1, I now know where point K is. Point K is the coordinate 3, 2. It then says, prove that quadrilateral BKDC is a trapezoid. BKCD, so I need to connect B to K, and then we have CD over here. So here's your new shape we're looking at. Now to prove something is a trapezoid, you need to show 2 slopes. The slope of BC, which I already know is negative 4, and I need to find the slope of KD, this new segment we've created. To get from K to D, I'm going to go down 4 to the right 1, which is negative 4. Trapezoid is easy. It's only 2 slopes. I just have to prove one set of sides are parallel. So I could say, therefore, BKDC is a trapezoid because one set of opposite sides are parallel. The next part says, state the area of triangle ABK. ABK. To find the area of triangle ABK, I need to find a height and a base. So height and base have to be perpendicular. Notice none of these sides are perpendicular to each other. So I'm going to have to drop in a altitude. I'm going to have to drop in a height. So if I take any point, A, B, or K, and draw a perpendicular line to the opposite side, I wind up having a height. One of them is easiest, point A. If I go vertically down from point A, that's 1, 2, 3, 4 boxes down. And then BK winds up being my base, which also has a nice, easy distance to find. 1, 2, 3, 4, 5, 6, 7 boxes. Now, you could do it by dropping the altitude from k, but it would be a lot more work. You'd have to find distances using the distance formula. Here we have this nice triangle with a height and a base that's given to us. So the area of a triangle is 1/2 base times height. So I can say 1/2 of 7 times 4, plug that into my calculator, and I get an area of 14. This one problem is putting together a lot of different things. It's having us prove something's a parallelogram. It's having us find the coordinate of a midpoint. It's having us to find more slopes so we could prove it's a trapezoid. And then it's eventually even asking us to find the area of a shape on the coordinate plane. Basically putting everything we've done since lesson 1 together. All right, here's a good time for you to stop the video. Try the homework questions, see how you're doing. Make sure that there's no issues or problems moving forward. Again, make sure you're trying these first, right? Watching the video and just going right through is not helping you, right? So try them first, see how you're doing, and then use the video to kind of see if there's problems or issues. If there's things that you don't understand, please reach out to me and email me. That's the easiest way to get to me. All right, so hopefully you paused the video and tried this. So let's just get to it. So point R is -2, +6. Point E is -4, +2. Point C is +4, -2. And the last point, which is point T, I know it doesn't say it there, but we know it's point T. We have +6, +2. So we have R, E, C, T. Look at that nice rectangle. Now, to prove something's a rectangle, I only need slope. I need slope to first prove it's a parallelogram. Then I need slope to say that the consecutive sides are perpendicular. No distance required at all for this problem. So I need to find the slope of all 4 sides. Slope of RE, positive slope line. We're going to go up 1, 2, 3, 4 to the right 2. 4/2, which becomes just 2. I need to find the slope of RT. So it gets from R to T, that's a negative slope line. I'm going to go down 1, 2, 3, 4 to the right. 1, 2, 3, 4, 5, 6, 7, 8. So I'm going to go -4/8, which reduces to -1/2. We like seeing this because those are negative reciprocals, making this a right angle. If I find the slope of CT, it's going to be 4/2, which is also 2. If I find the slope of EC, it's going to be -4/8, which is also -1/2. So before I could say it's a rectangle, I first have to say it's a parallelogram. So I'm going to say, therefore, RECT is a parallelogram because opposite sides are parallel. And again, you can do that by stating the sides that are parallel or just saying the sentence that the opposite sides are parallel. It doesn't matter. The next part of this, I'm going to say rectangle is a rectangle because consecutive sides are perpendicular. I know that they're perpendicular because their slopes are negative reciprocals. The next part says A is the midpoint of segment RT. So segment RT had a slope of down 4 to the right 8. So if I cut that in half, just go down 2 to the right 4, I'm at my midpoint, right? So the midpoint is the coordinate 2, 4. So we'll say that this is point A. So point A has the coordinate of 2, 4. It then says that we want to prove that triangle ACE is an isosceles right triangle. So ACE, here's your triangle. Now looking at that, where do you think the right angle is? At E, at C, or at A? I think it's at A. So because I think it's at A, I want to show that AE and AC are perpendicular. That makes it a right triangle. So I need to find the slope of AE. The slope of AE is a positive sloped line. It goes up 2 to the right, 1, 2, 3, 4, 5, 6, so 2 over 6, which reduces to 1/3. And I need to find the slope of AC, which is going to go down 6, 1, 2, 3, 4, 5, 6, to the right 2. So we have negative 6 over 2. It's negative slope, so it's negative, which becomes negative 3. That work alone is enough to prove it's a right triangle. I don't want to prove it's a right triangle. I want to prove it's isosceles right triangle. So I need to make sure that the distance of AE is the same as the distance of AC. So if I take points A and E and subtract their x values, right, the x values are going to be 2 minus negative 4 plus 4 minus 2. If you do that, you're going to get the square root of 40. I know you can reduce it. I know you could type it in the calculator and get a decimal. I don't care about that. I just want to see if these two things are the same. From A to C, right, if I take my C values, x value, that's 4 minus 2 squared, and then subtract the y value, so negative 2 minus 4 squared, that's also going to give me the square root of 40. So now I have enough information or enough work to be able to write my final sentence. So I could say, therefore, triangle ACE is isosceles right because two sides are congruent and perpendicular. Congruent making it isosceles, perpendicular making it right. And that's it. Hopefully you enjoyed the lesson. Hopefully you learned something from the lesson. If you're still confused or there are any issues, please reach out to me via email, and hopefully I see you soon.